David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, the vertex. So let's review. We just looked at the axis of symmetry. I drew my coordinate plane like that. Here's my parabola. My axis of symmetry goes right through the vertex. The vertex coordinates are h, k, and the axis of symmetry is the vertical line x equals h. Okay, so let's talk a little bit about that vertex. In an earlier video, we discussed how it's a turning point, where in this case the function is decreasing and then it passes through the vertex and now it's increasing. So that tells you that it's a turning point. Here's our vertex form of the quadratic equation. I want to talk about a couple conditions here. When a is bigger than 0, which means it's positive, the vertex is a minimum. And that means that the parabola looks like that. If my vertex right there, this is the minimum. In other words, it never gets lower than that. It does not have a maximum because it can just go on up forever. Similarly, when a is less than 0 or negative, the vertex is a maximum, which means that the parabola looks like that. And that means that the parabola never gets higher than that coordinate. So the vertex represents a maximum. Now, if you have a quadratic in whatever form, it's pretty easy to find both the vertex and the axis of symmetry. So we're going to do that from standard form. Here's an important point to note. We talked about this before. The vertex lies on the axis of symmetry. We're going to exploit that. It's right there. It's on the axis of symmetry. Okay, so here's a quadratic in standard form. Vertex is not apparent, but we can use it and we can find our vertex. So here's a step-by-step method. You might want to jot these down in your notes. The first one is find the axis of symmetry. So remember how that's x equals minus b over 2a. So that's x equals, now here's my quadratic, minus x squared plus 2x plus 3. It's going to be minus b, that's minus 2 over twice, what's my a? It's negative 1. 2 times negative 1. So that's going to be minus 2 over minus 2, which is 1. So the axis of symmetry is x equals 1. And so what that means for this parabola, if it looked like this on the graph, this line would be x equals 1. Okay? So we found the axis of symmetry. Now, read this carefully. Plug value for symmetry axis into function to get vertex y coordinate. So what we do is we take this value, we plug it in for x in the function, and that's going to give us the y coordinate of the vertex. So let's do that. This is minus 1 squared plus 2 times 1 plus 3. So 1 squared is 1, minus 1 plus 2 plus 3. What do we get? That's 4. So our vertex is v equals 1, 4. Okay? So it's pretty straightforward. That's how you find the vertex if you're in a standard form quadratic. Remember, if it's in vertex form, you just pull it right out of the equation. It's staring at you in the face. Okay, here's one for you to try. But I warn you, this one gets a little tricky. You're going to have to deal with fractions. So here's my function. F of x equals 2x squared plus 3x plus 2. Go ahead and pause the video and see if you can find the vertex. Okay, let's follow our steps. First step, find the axis of symmetry. That's x equals minus b over twice a. So minus b is negative 3 over 2 times a, which is 2. So that's going to give us minus 3/4. So we know already that for our vertex, the first coordinate is minus 3 over 4. Now we just need to find the second coordinate. And it's going to get a little tricky, because now we have to plug in negative 3/4 into our quadratic, and we're going to have to manipulate some fractions. So let's do that. If you want to pause the video and see how far you can get, let's do that. Okay. Now I could write f of x. I'm just going to write y, because truthfully, I'm looking for the y value of my vertex. I'm going to get 2 times plug in negative 3/4 squared plus 3 times negative 3/4 plus 2. Okay, so let's do some crunching. Negative 3/4 squared becomes positive 9/16. I'm going to square the top and the bottom of my fraction to get 9/16. I'm going to multiply 9/16 times 2. So that's going to give me 18/16. So this term becomes 18/16. Enter the first fraction. Now I've got 3 times negative 3/4. So that's going to be 3 times 3. It's going to be 9/4, but it's going to be negative. So minus 9/4. And 2 is just 2. So I'm going to bring that down. Now I have 3 constants. I need to add them all together. So I need a common denominator. I think I'm going to reduce that to eighths, increase that to eighths, and write that as eighths. So let's just do that. 18/16 in eighths is just 9/8. I just divided both of those by 2. Now to put 9/4 in eighths, I need to multiply both sides by 2. So this is going to become minus 18/8. And then 2 as eighths is 16/8. Okay, let's combine our fractions. So I have 9/8 minus 18/8. That gives me negative 9/8. Now when I go forward 16, I'm going to end up with y equals 7/8. So now I can put this up here in my vertex. So even though this got kind of ugly along the way, we ended up with a pretty reasonable fraction. There's my vertex. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.